Welcome to Brain Vision.
Okay, so we're doing chapter 26, problem 59. So it says a 45-volt battery of negligible internal resistance is connected to a 44 kiloohm resistor and a 27 kiloohm resistor in series. So let's write this out here. So we have 45 volts, and it's connected to a resistor and another resistor in series. 44 kiloohm and 27 kiloohms. And what reading will a voltmeter of internal resistance 95, so 95 kiloohms, give when used to measure the voltage across each resistor? What is the percent inaccuracy due to the meter resistance for each case? Okay, so if the voltmeter were ideal, then the only resistance in the circuit would be the series of the two. So we know that the R total is just 71 kiloohms, or those added, such that I equals 45 volts over 71 kiloohms, and this equals 6.338 times 10 to the negative 4 amps. Okay, so that's what the total current is, and if this voltmeter was perfect, then we don't have to take into account this at all, right? So we can take the measure across this one as, I'm going to write P for perfect. This is just given by IR1. So that's just 27.89 volts. You can do the same thing for the other resistor, which is just IR2. And this comes out to being 17.11 volts. So these are the ideal true voltages across each resistor. So if we put the voltmeter in parallel with the resistor, so imagine here we take our voltmeter, put it in here. We want to find its equivalent resistance. So now of this loop right here, Req becomes 44 kiloohms, or 1 over 44 plus 1 over R internal inversed. If we plug that in, this becomes 30.07 kiloohms. So now, this is the equivalent of the first resistor. So we now can need total equivalence, and that's just 30.07 plus 27 kiloohms, or this is 57.07 kiloohms. And that tells us that the current is then, of course, just 45 over that, or 7.885 times 10 to the negative 4 amps. And now, using this current, we plug it back in to figure out the voltage reading on 44 kiloohm thing, which is just this current times our EQ. So this is 7.885 times 10 to the negative 4 times 30.07 times 10 to the 3 ohms. And this comes out to a reading of 23.71 volts. So this is what the voltmeter would read on the 44 kiloohm, and this is what the actual voltage would be. So now let's do the same thing for the second one. Now we have 1 over 27 kiloohm plus 1 over Ri inversed, and this becomes 21.02 kiloohms. This means our current now becomes 45 volts over 21.02 kilo ohms. And that is 6.921 times 10 to the negative 4 amps. Okay, so now let's figure out what the reading is in the 27 kilo ohm resistor. And this is given by IRQ, or 6.921 times 10 to the negative 4 times 21.02 times 10 to the 3. That was amps, and this is ohms. If you plug that in, we should get 14.55 volts. Oops. So that's the reading for the 27 kilo ohm resistor. So now we know the actuals and the ideals for both. So over here on the very side, let's figure out the percent air here. So percent air is given by the reading minus the actual all over the actual times 100. So this is 23.71 minus 27.89 all over 27.89 times 100, or this becomes roughly 15% off. Okay, for the second case, let's do the same thing. Percent air, this equals 14.55 minus 17.11 all over 17.11 times 100, and again this is roughly negative 15% off. So in both cases the air is about 15% off, and it's too small in both cases. So we can imagine or interpolate from this that maybe the smaller internal resistance in a voltmeter reading will give less air, hopefully.